Okay, welcome back everyone after the break. Now we're moving into the next section, which is on mobile multimedia examples. So to start off with, during the break, we did see a couple of demo videos on what mobile TV looked like, and also the interaction of the mobile device with content, m-commerce or e-commerce, authentication, and the presence information as well, just to give you that example. But to go forward then, what are effectively the underlying technologies and capabilities that we have? So for all of these services to happen, we're actually talking about convergence. Now, some slides back, we talked about the convergence of telecom, the internet, and media. So we're also then talking about the convergence of services as well. So convergence is a term that's been used in the industry for a couple of years, and it really means a number of different things. But in this context, we're talking about convergence of services to provide that kind of capability that we saw in the videos. So, for example, one area of convergence would be on your mobile telephony device, which we call, for example, mobile triple play. The mobile triple play then is the ability to have mobile voice, mobile broadband, and then mobile TV, so hence the triple play. So if it was just normal triple play, then we would be talking about the convergence of voice on your PSTN, internet data on your ADSL, and then TV at home, for example. So one example of that is bundling services. So if you go to Telstra, you would then get your fixed line from Telstra, your Big Pond service from Telstra, and Foxtel from Telstra. That would be effectively a triple play service. In that context of the fixed line scenario, there's another concept that is being bandied around the industry is called quad play. So you go from triple play that we just discussed and you add mobility to it. So you have your mobile device, your PSTN phone line, your internet data line, and TV at home, and all four services then is a quad play offering. So in that case, you might pay $99 a month and you'll get access to all of these services, for example. So bundling's become quite important now for a lot of these operators who've traditionally had a fixed line network, a PSTN, which is your home telephone, plus a mobile network as well. So they've said to themselves, well, that's great. Maybe I can package the two together and give you a better offering. In that case, you're less likely to churn off or, for example, use Optus for your PSTN and then Telstra for its mobile network. So operators are using bundling strategies to try and keep you on their network. And, you know, if you get one bill that has all the costs on it, it's usually a lot easier. And people tend to prefer to have a one bill type scenario. So in terms of the services and the convergence of these services, in the case of mobile here, we're talking about mobile telephony, mobile broadband, and mobile TV. But how are all of these services coming together? Where is the convergence point? There must be a point that is actually bringing all these services together, really. And the mobile evolution, if you like, on the service layer or the application layer, developed a technology or concept called IMS, which is the IP Multimedia Subsystem. And IMS is really if you like, the convergence point that is able to deliver the TV, the voice, and the mobile broadband, if you like, on the service layer. Another form of convergence, if you want to call it, could be voice over IP as well, where we're bringing together voice and data to provide a particular service. So let's have a look at a couple of examples when we look at video telephony. What we've seen so far with video telephony is probably very poor usage. I would suspect that not many of you are actually video conferencing your friends if you happen to have a video camera and a video telephony service. You might have done it in the beginning, but actually what was very interesting is that a lot of the 3G networks around the world, well, all of the 3G networks around the world have the capability for video telephony. So anyone with a camera and a 3G phone can actually make a video call to somebody else, usually. Obviously, you need to have the back-end infrastructure from that operator to make it work. So, for example, if you took 3 Mobile when they launched in Australia, the big thing that they thought at the time was that video telephony would be a killer service and everyone would jump on to try and make it happen. But the interesting point is you need to know that the other person has a video telephony capable device, otherwise you can't call them. And you don't know, right? If someone says, call me on 0404 la la la, you don't really know. So there's one stumbling block that had to be overcome. And secondly, in order to actually make it worthwhile, you needed to have enough people out there with a video telephony device, right? My guess would be, 40, 50% of the mobile subscribers would need to have a mobile telephony capable device in order for you to even start to think about it. So it takes some time for the capability of the phones to get out there in the population of subscribers and then to be activated and then for consumers to want to use it. So you can see it's a very slow process. If you think about how often you change your mobile phone, would it be, how many of you change your mobile phone every 12 months or less? Okay, 2, 3, 4 of you out of, 15 or 20? How many of you would do it between 12 and 18 months? In addition, okay, a few more of you. 2 years, more than 2 years? Okay, we're starting to get to the entire group now, right? So if we take on average 18 months as a cycle for handset replacement, you're pretty comfortable with your phone, you've got all your address books and address lists on there, you're changing it every 18 months. So let's say you recently picked up a 3G service last year. So if new services come on in terms of the network and on the phone and from content providers, you're not going to jump out there and chuck your phone away unless you have a very compelling reason. So there's an intrinsic cycle of handset replacement which sort of slows down the take-up of these services. Seems obvious, but it's often overlooked. And that's what the industry has to sort of take heed, really. In order to get these services onto your phones, you need to really change these handsets. But interestingly, when 3G was launched, it came with video telephony, but it had the problem of not many people had 3G services at the time. Also, the cost of a video call was a little bit more expensive. Also, the quality of the video wasn't that great. And if you were doing it outside, the sun was too bright and everyone looked quite dark. So it wasn't really very practical, actually, in many ways. So in the same way, you might ask, well, is mobile TV going to take off? What's going to happen with mobile TV then? I mean, what needs to happen for that to be a success? In that case, you're actually getting video streaming delivered to your phone, so you don't have to worry about somebody else having that capability. So it's you and the network in that case that you're subscribing to. You need to have good battery life. You need to have a good contrast screen probably to use it. But more importantly, it comes back down to your data plan, doesn't it? Is that data plan going to mean that I end up spending $500 a month on data bills? Then I'm probably not going to do it. But anyway, interestingly, from a video point of view on your phone, even though the data rates are high, we're still not really seeing the services today. Australia has what penetration of the mobile subscriber base? Sorry, what penetration of the Australian population has mobile phones? It's 106. Okay, so the guys here last week were definitely awake, so that's good. So I didn't put you to sleep too much. So that means that everyone's got a mobile phone, at least, right? Of those 106% or the entire population of Australia, what sort of rough percentage have 3G phones? It's about 30-odd, 32%, I think was the number that was in last lecture, which is quite a sizable number. So if you take 30% of 22 million people, you have quite a lot of handsets out there, right? About 6.5 million. So that's good. So we have a very good starting base for 3G services. Not all of those phones, though, will have high data rate capability from HSDPA, though. They might be the early 3G phones, for example. So that 6.5 million might actually only be about 1 to 2 million, which is still quite large. So what we're saying then is that I would say that we're starting to get to the point in the Australian marketplace for 3G that services such as the ones we've seen with rich multimedia content, triple play, mobile triple play, could become a reality if the price is right, without using the cliche from that TV show. But as I mentioned, we aren't really seeing a fundamental change in the industry yet, so we'll see what happens. But on the most basic level, we have the video call, which is not being used much. We have the potential for video mail. So it's exactly the same as voicemail, but you use your mobile camera to record the message and it gets stored and someone can download and watch it. Streaming video is being used to some extent. People who are surfing these portals on Vodafone Live or Optazoo or so on, wherever it might be, are downloading video clips from time to time. For example, watching cricket. Big Brother is also possible to see on your mobile phone. Video conferencing is one of those services that everyone thought might be possible. But I'd say again, anything to do with video calling is probably unlikely to succeed at the present time, given the quality of the handset devices as well. I mean, if you look at the picture on slide 18 here, you can't really see the other people in this four-way video conference. It's a little difficult. So how is video actually delivered then to the mobile device should these services take off? So the video telephony service, for example, started off by using a protocol called 3G.324M. It's just a video protocol that was modified for 3G services. And that was actually a circuit switch connection. So do we know what we mean by a circuit switch connection now? So we're talking about a dedicated connection then between the 3G phone and the 3G network. And that's a 64 kilobits per second connection. So pretty slow data speeds. But if you think about how small the video screen is on your phone, 64 kilobits is probably reasonable for that size screen. And then you'd have a video gateway that would convert the video protocol into whatever video codec you needed to get to your destination device. So there's 4 examples here. It could be streaming on another phone, for example. It could be the video mail server in the operator's network. It could be for a video conferencing server. Or it could be converting it into a SIP video format using H.323, which means then that the mobile phone video could connect to a PC video, for example. Similar protocols to what you use on Skype video or MSN video, those sorts of things. So the whole idea was that someone sitting in the office or at home could video conference someone on a mobile phone, and that would mean that we wouldn't only be restricted to the mobile device for capability, right? Anyone who had a PC and an internet connection could make a video call to a telephone, which would have been really interesting. But again, it didn't take off, and my bet is it had to do more with the pricing plans and general awareness around in the marketplace as to why it didn't take off. So if we look at the other type of service I mentioned, which is streaming. So when we talk about streaming, it's a download type service from the operator's content or the application provider's content to the mobile phone. And there's then again 2 types of streaming. There's circuit switch streaming and packet switch streaming. So circuit switch streaming would be over a circuit switch call, and that would be via the MSC server that we talked about before and the circuit switch core network. And the packet switch streaming would be via the GPRS core network that we looked at last week. But at the end of the day, you will always see gateways in between that will typically convert from one video codec or one video type to another. But at the most highest level within the network, you would always have the video server on the top right and some kind of content delivery mechanism. So that content delivery server or the gateway would convert the video streams from the base format or the raw format to your particular mobile device. Because every mobile device is quite different, so you have to recode and represent the information to the device in order for it to work. So that's the general kind of network architecture. So what a number of operators were doing was building these video servers and content delivery systems. And if you think about video and the movies you might have stored on your PCs at home, they obviously take up a lot of data and a lot of information is stored there. And managing and manipulating it and having encoders and decoders to make these things work is actually quite an intensive business. So if you're providing a news type service, if you think about the new types of feeds that come in from the field, from reporters, you then have to go through production, editing and copywriting and sort all of that stuff out and then put it onto the content servers and then deliver it. It's quite an intensive process. And if you look at the mobile operators today, they don't have that sort of skill, do they? They're good at building mobile networks, for example, operating and running them, and setting up content and billing and customer care, which is all the sorts of things that we're familiar with, but they don't have those sorts of skills. So the merge then that I talked about of telecom, media, and internet is starting to become more interesting because the media companies are the ones that are brilliant at those sorts of things. But they don't have any skills in mobile networks and fixed telephony networks, do they? So you can see a natural complement or marriage between these two types of industries or sectors, if you like. So will media companies buy telecom operators? Will telecom operators buy media companies? Will they form joint ventures? It's a sort of question that we've been looking at for a couple of years now, but there hasn't been any major traction yet. Because I guess everyone's still trying to see how the industry will play out. But if we take an example of mobile TV, so we can actually deliver mobile TV via two mechanisms. We can either use the existing mobile network. We can use that circuit switched and packet switched connectivity that we talked about. Or we could use broadcast networks or dedicated broadcast networks such as TV broadcast networks like Channel 7, 9, and 10, that type of concept. So the industry looked at delivering mobile TV in those two fashions. So naturally, telecom operators that had mobile networks were interested in the mobile network approach, and broadcast and media companies who had broadcast towers and those type of infrastructure were more interested in the digital video broadcast approach. So what happened is digital video broadcast standard was then developed for the mobile phone. So, for example, the HD TV that you get at home was modified so that you could deliver some kind of digital video broadcast to your terminal. So what that would mean is that your mobile phone then would have to have an antenna to receive the terrestrial broadcast in that case. So that would be I don't know if any of you live near St. Leonard's or Tarman, for example, you'll see the very large TV towers. The SBS tower and I think 7 and 9 are there. So those are the broadcast towers that I'm talking about. They can be adapted then to deliver mobile TV services as well, which cover a very large area as opposed to mobile towers for mobile networks. The two main standards that have been developed then are DVB-H, which is digital video broadcast handheld, and on 3G networks. And that technology is called MBMS, which is Multicast Broadcast Messaging Service. A pretty long-winded name again. Essentially, one uses the mobile network then, and the other uses the broadcast networks. And then there's been a whole host of other technologies like media flow and DMB and other such things, which are proprietary technologies that haven't really taken off. So what kind of broadcast or TV delivery mechanisms are there? We have the first main kind, which is the most basic form, called unicast, which is simply from the content server to the actual phone. So it's in a one-directional manner. So what that means is you take up one channel or transport channel in the mobile network. You take up the entire resources in that network for that one data stream. In a broadcast fashion, for example, which is the picture on the right, and the example here is the 3G MBMS technology, what you would have is you would deliver a video stream to one base station, and that would transmit that signal out to all mobile devices that had subscribed to that service. So if you take the mobile cell at the bottom side on the right there, you've got 6 mobile phones, 3 of them are green, and they've subscribed to the green channel in that case, which is being broadcast to all of those 3 mobile phones. So you're really only using one transport channel for that one green TV channel, so to speak, which is far more efficient. In a unicast approach, as is shown on the picture on the left, you would have to have a dedicated radio link to each of those phones in that case. So there's some benefits and efficiencies by broadcasting. And in a mobile context, you broadcast at the mobile tower or the base station. So if we look at the mobile TV delivery, what are the pros and cons? In terms of the cellular spectrum, so mobile networks, if we look at, firstly, unicast, the main benefit, of course, is that the mobile networks exist today. The type of connections that you have, the packet connections that you have today when you surf the web is a unicast connection. You make a PDP context attachment to a mobile network. And if you've covered the GPRS course, you might be familiar with the PDP context, for example. And once you've set up that PDP context, then you have an open IP address and a pipe, and then off you go, you can surf the net. So that's very easy to set up. But again, you're taking a dedicated resource just for your call. In most 3G networks today, you actually have a lot of spare capacity because most of the network subscribers are on 2G systems, aren't they? If you take the Australian situation with 70-odd% of subscribers on 2G networks, the brand new built 3G networks from all of these operators have a lot of spare capacity. So it actually works out quite well to start off a service that is capable to be launched straight away using, for example, unicast streaming. So all of the portals, for example, that you have access to typically use this unicast streaming approach. But the big problem, of course, is that as this number of subscribers that connect to this mobile TV service start to grow rapidly, you're starting to chew up the network capacity quite quickly. So then you need to start potentially moving into a broadcast type technology or approach. And that situation, we, in 3G at least, use MBMS, and that's only recently being launched in some markets around the world. So it's quite new. The issue here, of course, is that it uses up a lot less network capacity, which is fantastic, but it relies on you having an MBMS capable phone, which again is a big issue for a number of operators. If you're only changing your phone every 18 months, the take-up then of MBMS is going to be fairly slow. So I don't think you'll see that moving quite rapidly. If we look at the broadcast spectrum then, which is using large towers to cover an entire city area, for example, like in the same way of TV, we have DVB-H then in that case. The big problem here, of course, is that the mobile network operators aren't interested in promoting DVB-H, generally speaking, but the broadcasters are. And they don't have much weight in the telecom industry, so it's been quite slow to take up. You tend to have a lot more spectrum available for broadcast, which means you can have a lot more TV channels. But the problem with broadcast is, like TV, when you switch on channel 7, can you send an SMS to channel 7 and say, oh, I want to do something. I want to buy this new TV that I saw on your ad. You can't do that, can you? There's no feedback. So intrinsically with broadcast, there's no feedback capability. And that's one of the advantages with having mobile TV via a cellular network, where you're downloading a TV program or a trailer for a movie, for example, and at the same time you could be seeing a banner ad at the bottom that says if you send a text message to 155, you can get a 10% discount at your next movie at Hoyt's, for example. And then you send the text and off you go. So there's that interactivity, right? So that's the capability that can be offered by the mobile scenario, if you like, that's not possible by broadcast. So there's pros and cons then in that case. But in terms of seeing mobile TV on mobile cellular networks, it's typically happening in a unicast fashion today. It'll probably move towards a broadcast approach of some kind. One case that was interesting is Hutchison in Italy, or 3 Italy. They're a mobile operator, right? They didn't do anything else other than mobiles and offer the services in exactly the same way as here in Australia, but they actually bought a TV station in Italy. And they used DVB-H actually as a mechanism to deliver TV to their mobile subscribers, which is an interesting example of this convergence, if you like, of telecom and media then in that case. So, but those sorts of examples are fairly rare today. So when we talk about TV then, how has the experience evolved? What we are currently used to when we look at channel 7, 9, and 10, and even generally pay TV for that matter, it's what we call scheduled TV. You have a program at 9:30, you connect, at 9:30, for example, you might have your favorite sitcom, you sit down, you watch it, and then it's over. So that's what we call scheduled TV. TV on demand is starting to happen a lot more so in pay TV. So, for example, you might be able to download a video anytime you want, for example. Or you could watch reruns of various TV channels. But push TV then is something quite different. That is when a mobile operator, for example, sends you a free clip of the last 5 goals that Manchester United scored, for example, against Arsenal. Then they might entice you with advertising, or they might prompt you to another link, which then takes you to the scores on club pages, and then from there you might download more TV shows or TV clips from the soccer, or potentially you buy merchandise from, for example, Manchester United. So that's another type of approach that is starting to happen more and more. So we've got really 3 types of TV services, which are the scheduled TV, push TV, and TV on demand. Now, of these 3 services, how are they going to be delivered? What is the best mechanism? For scheduled TV, broadcasting works quite well, doesn't it? Which is exactly how we do it today. You just, have a schedule every day, Monday to Sunday, and off you go. No one really cares too much about it. So scheduled TV is probably best delivered by some kind of broadcast mechanism. Doing it via unicast would potentially be very expensive on a mobile network, unless it was a broadcasted solution like MBMS on mobiles. If we take push TV again, because it's a one-off and it's specific to you as a subscriber, it probably makes more sense to deliver that via a unicast or broadcast on a mobile network. You're not going to push. So say, for example, if you had a broadcast TV solution on DVB-H, you're not going to push it to every single mobile device in the entire of Sydney. You do want to select who actually receives it. And TV on demand, again, then is probably more suited for unicast, right? Because you're the one who's subscribing to the service. So although this picture shows a somewhat limited application for DVB-H, it is very much more skewed towards scheduled TV. And mobile network delivery of TV then can cover a number of different types of applications in that case. So if we look at the evolving TV experience in the same way that we looked at the capability of the phone from the multimedia perspective, we have gone from the very poor, dumb browser approach on WAP, if you like, with downloaded streaming, to video telephony, and then on to some kind of interactivity, which we do see in many markets around the world, where you do have, I don't know if you can see it from this slide, but the interactivity phone picture there, you can see the text at the bottom of the picture that's prompting the subscriber to send text messages and then receive promotions for rock concerts and movie campaigns and those sorts of things. And then later on to a more program guide approach where you subscribe to a service, and when it's scheduled, you get a message, and then you connect to the channel and start watching it on your mobile phone. So if we look at the consumer perspective, again, it's switched from that browser-based approach to what we call a channel surfing. What's been very important from a mobile TV perspective is you and I are very used to sitting in front of the TV with a remote and just switching channels very quickly, right? So the channel switching time needs to be also very short. You don't want to have to wait 10, 15 seconds to switch channels. So for example, the video we just saw, the guy probably rattled off around 10 different channels that he was able to subscribe to on his Mobi TV. If it's going to take him 10 or 20 seconds to switch to each channel, you're going to get pretty frustrated by the end of it. So one of the channel switching has become a very important part of mobile TV delivery as well on mobile phones. But that's been solved now. So I think many operators are starting to see successful launches of mobile TV. So if we look at an interactivity example here, we can see in this particular slide, it's who is the hottest singer? Is it Britney or Christina Aguilera? Click yes or no and pay 50 euro to proceed. And then you can actually see the results within 3 minutes, and you might get a poster or a wallpaper that you can use on your phone. So for the ladies out there, it might be I don't know, Brad Pitt or maybe somebody like that, I don't know. But these are some of the ways that mobile users are trying to, mobile operators are trying to generate more revenue. So from a very basic streaming service, they're actually gaining additional revenue from the data download, the click of the streaming clip itself, plus they're also making money on the SMS that you send, which is quite easy to deliver. So in a couple of clicks like this, you could be down a few dollars. Moving on to the next slide, 31. This is an example of some screenshots. So the idea here is that if you remember when we looked at the second section, which is the mobile multimedia examples, we talked about this triple play, right, of mobile broadband, voice, and TV. And if we looked at it from the context of a fixed line, where we had phone at home, ADSL, TV at home, and the mobile telephony device. Ideally, what we want to have is, in either of those scenarios, is the same look and feel, right? So what I should be able to do is watch TV at home, and then when I leave home, I should be able to transfer that TV channel to my mobile phone as I'm walking out the door and be able to see it on my phone. Hop into the bus and then continue to watch the TV show that I was watching at home. And the idea here is to be able to have the same look and feel. So the mobile client then would look similar to what your TV would actually produce. It's kind of like a bit of a marketing spiel, if you like, but that is the espoused position of a lot of these converged services, is to actually see that capability. The benefit, of course, is then it's easy to use. It's the same interface, whether you're at home or on your mobile device. So if we look at yet another application, this is called a whiteboard application. So you could start off with a generic, blank page, and then you could scribble your name on it or a picture, and then you could send it off to somebody else. That's possible today on MMS. It's quite easily done, but most people probably haven't even tried it out on your phones. But it's a pretty simple thing to do. I suspect it hasn't really taken off all that much at the moment. But where it could actually be very interesting is if you combine that with a map service. So we're starting to see some convergence in services now, where we combine the whiteboard and the map service. So how many of you have, trying to find your friends in the city and you're not really sure where they are? And you give them a call, and I'm on this corner of King Street and George. How do I get to Elizabeth Street, where the coffee shop is? And then you try and describe it. You invariably get lost, and whatever happens, then 10 minutes later, the coffee's cold. So you've blown $3.50 on a latte when you could have had a fantastic service like this, for example. So in this case, you would see a map on both mobile phones. And your friend could, for example, use the whiteboard application to overlay the dotted lines and show you exactly how to get to the cafe. I can think of a number of examples where that would have been very useful, but I can't do it on any phone that I have today, for example. I think Google might have something like that, but I haven't really looked. But then again, it's about user awareness as well. How many of you, or us, for example, can actually use the phone to make that happen in an easy way? It should be very, very simple. If it's anything more than hard, then no one will ever use it. So I could say that we're starting to see these sorts of things happen. The responsiveness of these applications should be good now that we've got good data rates to our mobile phones. But what we're lacking is the applications. And these applications, anyone can actually create. You and I could set up a company and get a few software engineers together and make something like this happen. So what we're likely to see in the future is a lot of little companies that are growing and starting up and delivering these types of services that are using the underlying bearers and technologies that the mobile network has to offer. When you compare that with GPS, which will then provide a very accurate location of where you are, then you have some very powerful services. And then on top of that, again, you could combine presence, for example. So let me give you another example. I'm just being creative here. Friday night, finished work at 6 o'clock. You flip open your phone and you see that there's 6 or 7 of your friends that are finished work and they're wandering around the city. You send out a message to all of them and say, look, I'm meeting up at the establishment. Let's go for a drink. And we're meeting up at 7. And then we're going to catch a movie at 9. Anyone want to join? 5 of the guys say, yep, definitely I'll come for the drink, but only 2 want to go for a movie. And then maybe you can buy your tickets online even before you get to the cinema as well, and also pick your seats from your phone. It's all very, very useful use cases that, many of us could see ourselves actually using. But again, still early days yet. I haven't seen any real serious examples. So now this is a really interesting use case. It says one day at the Happy World Cafe, which is a pretty pathetic title. I think I'll change that in the next set of slides. So I look forward to any names of cafes that you might have that I should use in the next set. But anyway, this also overlays the interaction that the mobile networks and the phones will have to undertake from a signaling point of view in order for these services to work. So I've only shown 4 slides within your lecture material here, but the animation on the screen actually has a lot more. So we'll go through them very quickly one by one. So we have Helen Carlson, who's a student, and she's wondering what her friend Susan is doing tonight. So she takes open her mobile phone and tries to make a session setup connection with her friend Susan. So that session setup is actually similar, or it's exactly like setting up a PDP context between phone A and phone B. In this case, it's actually a voice call, so she's setting up a voice connection, and she's saying, hi Helen, how are you? What should we do tonight? Why don't we watch a movie? Helen says, pretty good. Susan says, what do you want to see? And then she says, I've seen a trailer for a new film on the net. Let's see it online together. So Helen then, who's the recipient of the call, says, I'll get the trailer and I'll send it over to you and you can have a look. So what Helen does is she sends the video server web address to Susan. And then Susan is able to connect to the video server at the same time as Helen is. And then they're both streaming the video services at the same time to each phone. So as you can see here from a signaling point of view, there's a lot of messages that have been flying around between each mobile phone, between the phones and the servers and the mobile networks. So the protocols and the technologies underlying to make all of this happen are fairly intensive, but certainly not impossible. But you and I don't need to see that, of course, right? All we wanted to see is the actual movie trailer at the end of the day. So then they ended up watching the movie. Helen asks Susan, what do you think? And keep in mind, this conversation that I'm playing out to you now is all happening over voice at the same time that you're downloading packet data to your mobile phone. So what you're doing is you're actually seeing a convergence of voice and then packet data on your phone as well. So another example of convergence. And if you think about it, if you had an earpiece on your phone, you could look at the video on your phone at the same time as you're talking. And then it actually becomes possible. Obviously, you can't watch your phone and talk to it at the same time unless you're on a speakerphone. That's, again, another way that it could potentially happen. So Susan says, okay, she loves it. It's great. She wants to go and catch the movie. Do you know where it's actually playing? No, she hasn't checked that yet. So what happens next is Susan says, let's have a look at the theater guide. So she clicks on the link on the phone for the theater guide and sends the web address to Helen. So it's www.theatre.com, and they look at the web page and they try to work out where the next session is, which works out pretty well for both of them. So they end up going to the Orion Theatre, and then she says, look, we've got a bit of time. Why don't we drop by and have a coffee before we head off to the theatre? And the thing is, though, that Helen doesn't know where it is. And she sends, again, the details of the cafe, but not a web address this time, but a live streaming video because she's standing right outside the cafe. So she turns her camera phone around and shows the cafe and the neighboring streets and sends that video footage live to Helen. So she goes, oh, I remember where that is. Okay, I'll come over, but can you try and help me find it? So this continues by using then a positioning service, which is the GPS, for example, that we talked about. So what happens is Susan gets her position from the positioning system and sends that over to Helen. Helen's map service then connects up and then shows her where the actual cafe is. So the map pops up with a "you are here" type picture and ends up with a dotted line showing where she needs to go, the shortest path. And then she realizes that it'll only take 5 minutes, and off she goes. And she says, "See you later, bye for now," and they both end up meeting up for a coffee just before seeing a movie at the Orion. And then they finish up by closing the session, tearing down the voice call and tearing down the packet connection. And there is the life of Helen and Susan. Two very, very capable mobile phone users, I must say. But they're very proficient at how their phone works. But you could see that it was very easy to use. Click, punch, that kind of thing. And talking and using at the same time. Again, these slides were created several years ago, 3 or 4 actually. But it's still very, very relevant today. And I know personally I would find this extremely useful to do. So we're requiring a number of things to happen from the network, from the operators, from the service providers, the application servers, the device manufacturers, the capability on the phones. A lot needs to happen in order for this entire industry to really take off, so that you and I go beyond voice and text messaging. So that's something. I hope that was interesting. It just goes to show you all the signaling and all the back-end parts and why the network is very important in all of this. All right, then the next section that we're moving to is charging. You can't do all of these fancy things without paying some dollars for it, right? It doesn't come for free. So how do you go about charging for this if you're a telecom operator or a service provider? How does it actually work? So let's go back to the UMTS bearer model that we looked at last week, and just to refresh you on what the bearer was. So if we look at the mobile network, we have the user equipment at the most basic level, which is the terminal, connecting to the base station or the node B, and that then connects to the radio network controller. The radio network controller, as you remember, can run or control, if you like, anywhere between 100 and 300 or 400 base stations. So it covers a very large geographical area. And the RNC then connects to a core network. And the core network is broken up into 2 parts, the circuit core network and the packet core network. And that end-to-end connectivity then is what we call the full service or the end-to-end service. However, the UMTS part is only between the user equipment and the edge of the mobile core network. In this case, it could be circuit or packet or both if there's a combined service offering. So as I've explained how the network is built up, in the same way the bearer services break down into the various constituent components. So at the most basic level, we have the radio bearer service, which provides the air interface capability and capacity and mobility. And then we have some backhaul, which is the IU bearer or the transport bearer, which takes it back all the way to the core network. So these radio bearer services, we'll cover them in a couple of lectures as well. They need to provide the right data speed. Is it 128 kilobits? The right latency and throughput. The right quality of service, for example. So, I mean, if you think about quality of service, if I'm just surfing the web, like looking at the theater guide that Helen and Susan were, I'm okay with the best effort packet service, right? It doesn't have to be real time. But if Susan is streaming video to Helen showing the cafe, she needs to have some kind of real-time capability as well. So these bearers need to be quite flexible. They need to be able to offer both best effort and real-time, different data speeds, all within the confines of mobility as well. So it starts to get very, very complicated. Now, previously, mobile networks only need to worry about mobility of voice and SMS, a pretty simple proposition. Now we're handling simultaneous video, voice calling, on top of mobility. And all of these services then need to be delivered via these bearers at the most basic level. So when we're talking about packet data, we have something called an APN. Now, you might be familiar from the GPRS course that you may have done, that this is the access point network. Effectively, this is the, if you like, the beginning part of the internet for the mobile world. You get an IP address and some connectivity, and from there you can go out to the open internet. So in the early days when 3G was just being standardized or started, there was a vision that you could have multiple APNs. So each APN would connect to a different service. So one APN would connect to the location-based service, for example, for positioning. The other APN could connect to the map service, and then you might have another APN for the web browser. Each of them would have a different IP address and associated quality of service. And that would get around the problem of having to establish a real-time connection for everything, thereby taking up a lot of resources and network capacity. But the problem you have is that the mobile phone then needs to monitor and take into account all of these different types of APNs, which gets quite complicated for the mobile device. But anyway, that was the original thinking at the time. So that's why you have, for example, a primary PDP context and a secondary PDP context, ultimately to deliver these multiple different types of contexts. So you could set up, for example, several secondary PDP contexts and have one primary for the overall connection. So at the same time, at least in this slide, it shows you the connectivity of these different APNs. In this example, we're connecting to the operator services, so the WAP portal that I talked about. We have one APN, which is the MMS service, and then another APN for the open internet, which is the off-net services. So the on-net services are operator portal, the MMS services, and the off-net is the internet in that case. So what do you think operators are likely to do for off-net services, which are not operator-specific? When you set up an APN, you're probably wanting to have a very basic and rough service and not guarantee too much. So what some operators have tried to do is to provide better quality service for the APNs that are relevant for their network, but for off-net you get only the most basic service, best effort, and probably at a maximum bit rate of 64 kilobits per second. So although you can get off-net, it's going to be a very, very average user experience. And the whole idea there, of course, is that if the operator has a very interesting portal, then you'd want to surf on that instead and therefore use their services and then end up clicking on some kind of link that'll cost you some money of some kind. So what kind of services are out there, really? Well, at the top level, we have, well, we talked about gaming, voice, media, what sort of applications, email, chat, all those sorts of things, both for consumers and for business applications. So businesses, we refer to them typically as enterprise applications. So the types of quality of service that are required come in four forms. We have two that are real-time. The first is conversational, and the second is streaming. So conversational is exactly the voice services that you and I are typically familiar with, where we have a dedicated, usually circuit-based connection, guaranteed bit rates, and high levels of quality of service and low latency to make sure that the real-time services get there in time, and there's no jitter or delay. For streaming services, we can accommodate a slightly worse service with a bit more delay. It doesn't have to be as good a real-time service. So for example, if you're streaming a video service or an application, you tend to have sometimes very large buffers in the recipient device, right? So if you're buffering enough, what you do is when you're streaming an application, you can buffer up to a couple of seconds worth of video, maybe 10 or 20. And if there's a break in the radio connection or there's not enough capacity, you can still see the video playing on your phone. But when that link comes back up again, you try to catch and fill up the buffer as quickly as possible. So if you've seen streaming services like if you're watching, or if you're listening to radio stations on the internet, that's exactly how it works if you're streaming. Oh, YouTube is exactly that same kind of service where you can buffer. If you ever try and watch YouTube on a really slow data connection, you'll see that it's constantly stopping and starting. But if you pause the YouTube connection to start with, let that red line go all the way or halfway down the line, then you've effectively buffered, haven't you? and then you can press play, and then if you're watching it over dial-up, then it'll actually finish completely without any jitter or stopping or starting. So what we have then is, if we go back to slide 54, is a number of different services. So we've looked at the different quality of services that are capable. Conversational and streaming are real-time, and the two best effort ones are interactive and background. Interactive is not really used, so background is effectively what we call best effort service. We can have access to an ISP, which is the off-net that we talked about, or corporate access. So the type of corporate access I'm thinking about here is a connection to a VPN or a virtual private network. So I'm out of my office, I use my mobile phone, and I connect to the mail server within the company. So it looks as if I'm exactly within the office environment. I could be on my laptop, connected via the corporate VPN, and it looks like I'm connected to the LAN drives that work via my laptop, although I might be sitting in the cafe with Susan. The other applications could be web access. It could be also free of charge MMS. It's a number of different things. So if we move on to the next slide, this shows you another example of how we might be able to capture these services. And that is by using a single APN instead, rather than having multiple APNs like we looked at previously. So in this case, we have what we call a multi-service access point node, or access point name. And that covers all of the services, whether they're best effort, real-time, corporate, consumer, VPN, it doesn't really matter. But the problem that we have here, of course, is that when we have one APN, we actually have really only one quality of service. We have one IP address, and we don't really have an idea of what services are actually being used within this single APN. So this created a need for what we call content filtering or content surfing, essentially. Content spoofing. So what we're actually doing is we're looking inside the IP packets and trying to understand whether this is an email, or whether this is an MMS, or whether it's a streaming video. And if any of you have done some kind of data networks, you don't typically break the protocol layers, do you? You don't go into IP packets and look into the headers and try and work out what's going on. It all needs to be done in a very nice fashion. But this is something that has started to come out in the industry, which is the ability or the need to actually sniff into the IP packets and see what services are being used. Once you've actually figured that out, then you could actually charge differently for each of these services. So for example, if you're sending a text file, for example, at 50 kilobits per second, an operator could charge you maybe, say, 10 cents for that. But if you were sending a picture or video streaming at 50 kilobits per second, they could charge you maybe $1 for that, for the same data rate. So operators are very interested then to understand your user behavior, what services and applications are being used. Okay, now we move into the next section, which is the IP multimedia architecture and standardization. So this is the last piece. And IMS was effectively created or driven by the need for mobile network operators to try and control that revenue, to try and ensure that content providers and service providers weren't stealing the new opportunity in the new sort of telecom convergence, or the convergence of telecom and the internet and the media. So what the mobile operators wanted to do is to create another set of infrastructure that would be the convergence point within their network. So that would force all of the content to be on net, as we talked about before. So the types of services were, as before, fairly basic: voice calls, messaging, enriched by real-time services like streaming, for example, and then moving on to plain dumb services like, mobile broadband, which is simply data. So the whole idea here then is, if you see in the next slide, slide 58, is if we look at the infrastructure from a different perspective now, we start off with the radio access network, which is, in this particular example, it could be a GSM radio network or a Y-band CDMA network. It could be WiMAX or wireless LAN. And we would be connected to some kind of generic IP infrastructure. And then in the back-end network, we would have the core networks for circuit and packet. And then higher up in the network, we would actually have the internet and the content servers. But what we would actually need is policy control to start off with. We would need to ensure that we can authorize the users, that we're being able to create connectivity between mobile user A and B, and that was some of the examples we saw in the lecture. What becomes very important when we have multiple services then is also to make sure that we have the right quality of service for each of those connections. Also that we have the right level of security. So if we're looking at corporate data connections like IP VPNs, we want to make sure that we have IP security, for example, connecting the mobile device to back-end gateway or the core network. Also, we need to look at the last piece, which is flexible bearer charging, or, for example, what I call the packet spoofing, looking into the packets and trying to see which services are being used. So all of these different areas are new for operators in the convergence of the data and telecom and media in this case. All very, very new concepts for many of the operators. So if we look at a high-level call flow as an example, so we have Aria and Steve on their mobile devices. We have the IMS network in this picture, which is the IP multimedia box in blue. We have a home subscriber server, which is very similar to the HLI in a mobile network. That contains all the subscriber data. We have a media resource function, and that is essentially the transcoders and the encoders that we talked about, the content delivery mechanism. And at each end of this network, we must have something that will set up the call and manage the duration of the call and also the convergence of various types of services. So we might start off with a voice service, we might add a packet service, and then we might drop the packet service, but we might want to continue the voice service. And then at the very topmost level, we have the application server, which actually has the content. In this particular case, it could be a web server for theatreguide.com, or it could be a map service, for example. Now, the signaling protocol that's being used is called SIP, which is a Session Information Protocol. So the Session Information Protocol, SIP, is an IETF standard, or it's an internet standard. So Skype, for example, uses a SIP type variant in its proprietary implementation, a similar kind of concept. That's what allows all phones then, sorry, not all phones, all PCs to connect to each other via a common signaling protocol, which is SIP in this case. So Aria's SIP phone connects to the session control function, or the CSCF in this case, and that then tries to find where Steve is in the network and then makes the appropriate connection. And then finally, the application server is brought online to set up the service. In this connection or situation, it's actually a voice service. So the application server is a voice gateway, which sets up the call between the two users. So the CSCF in this example is only there to set up the session, but the actual call path, as you can see, is the big black arrow at the bottom. It goes from Aria directly to the media resource function and then out to the other mobile device. So the CSCF, if you look at it from the mobile context, is similar for voice in 3G for the MSC server. So the MSC server in the circuit switch core network is analogous to the CSCF here. If we're looking at a packet connection, for example, in 3G, it would be the SGSM, is also a control node. The connectivity then underneath that are the routers that connect the networks together. So in this situation, I've talked about quality of service becoming quite important, and it becomes very key because A, you want to provide the right type of service with the right type of user experience, and with each associated quality of service, you want to charge differently as well, right? So as I mentioned, cheap browsing on best effort, you could probably give that away for free, but that same capacity, if they're streaming services, you might want to charge more for that. So operators are having to build in quality of service mechanisms in order to control these different types of services. If we move on then to the IMS architecture, you can see here exactly how the network looks like. And of course, we're talking about a packet-based service in this case. So any voice services would be carried over packet, and the data is naturally carried over packet as it is today. So in this slide 61, we're looking at the user equipment and the access network. So the access network is the radio access network that I'm referring to here. And that connects to the packet core network via the SGSN and the GGSN. So the SGSN is actually setting up the packet mobility aspect of it, and the proxy CSCF is the one that's controlling the session on the application level. So the yellow bubbles are really the service layer, and the connectivity and the control are the green layers, if you like, or the green bubbles. So you have, for example, then a number of different components within the IMS subsystem. And I won't go into this in too much detail, but just to skim through these slides, but introduce you to a few of the concepts. So the proxy CSCF is the first node that is encountered in the IMS subsystem, and that probes the interrogator CSCF for information around the HSS, which is the subscriber database. So is this user subscribed to the map service? Has this user subscribed to the packet data service, etc., etc.? Once all of those authentication and verification have been complete, then what you find is a connection is set up from A to B via the SGSN and the media resource functions, which are the bottom parts of the network. So very similar to the slide 45 that we looked at a little bit earlier. So in this next slide, 62, it introduces the HSS, as I mentioned, which is exactly the same as the HLR. So no different in any way, shape or form. So three things to keep in mind, actually. We have connectivity at the most basic level, which is what allows the packet connection to work from A to B. We have the signaling components, which are governed by the blue boxes or the CSCFs. And then the last piece of the puzzle, essentially, is the gateway protocols or the gateway nodes. So these gateway nodes can convert, for example, from a voice over IP service to a PSTN service. So if you think about if you're familiar with Skype and Skype out, so if you have a Skype out type service, you might be on your laptop or your PC, for example, on Skype, but you're calling a fixed line number in another country, right? So you're connecting two different networks together. One is a voice over IP network, and the other is a proper PSTN network. So at some point, you need a gateway to convert the voice over IP to the PSTN format, if you like. So that's what these gateways are typically involved with. In the same way, we don't realize it today, but if you take a 3G phone and you make a voice call to someone who only has a 2G phone on a 2G network, there's actually a translation and a video and a voice codec change that's being done in a network somewhere that you're not familiar with. I mean, you don't see it. It sounds the same. Everything works fine, but it all happens in the back end of the network. So this is then all possible with all of these extra nodes. So IMS essentially is the new blue nodes that we see here in slide 63. They provide very similar functionality and on a high level as we see in the core network for circuit switched and packet switched. The only difference here is that it's handling all the services from a packet point of view. It handles the authentication, the authorization, the signaling, and then the connectivity. And more importantly, it handles the convergence of all of these services that we looked at previously. So now we move to the last slide, actually, which is or second to last slide, or number 65. Just a very high-level picture on the signaling protocols that are used here. So in this slide here, we have the user equipment. We have GPRS, which effectively is the packet core network. And then we have the IP multimedia system, which is the higher level application system that we looked at. So we start off by first setting up a bearer. Now, we talked about bearers a couple of slides before for a packet service. And in this process, we use the standard GPRS attach procedure. which is in GPRS, which is also in 3G. And once we've picked up a PDP context, an IP address, and a different type of quality of service, we've completed the PDP context activation stage. Then what we have is a set of signaling protocols that try to find the appropriate CSCF, which is the IMS subsystem node, to set up all the signaling protocols. Once that's been discovered, we make a connection from person A to person B. Once that connection is made, we then need to connect to an application server, right? We need to connect to the actual service that we're looking at. So we have an application level registration process that happens. So within each of these gray boxes, there's probably 10 or 20 different other signals and messages that are flying between the mobile phone and the back-end network in order to make all of these things happen. But this provides you with just a high-level view of the basic steps that are taken in order to set up an IMS service. So if we move to the next slide here, we can see that the actual protocol stacks that are involved. We have the user equipment, the UTRAN, which is the 3G radio access network, the 3G packet core network in the form of the SGSN and the GGSN, and then the application level layer or server, which we've shown here as the host. Now you'll see the picture on the top here is actually on a very high level showing you the bearers that we looked at in the UMTS bearer picture. So we have the RAN bearer, we have the core network bearer, and beneath that we actually have the transport bearers. And then we have on top the end-to-end connectivity. So that end-to-end connectivity is of course on the IP level. And this example is showing IP version 6 actually as a connectivity protocol that's being used. So it's an IP version 6 phone with SIP capability connecting to an IP version 6 application server in this case. Some of you might be familiar with the protocol stacks that you see here in the SGSN and the GGSN, and these are the GPRS protocols, like GTPU, which is the GPRS tunneling protocol, and UDP and IP, for example, which is standard IP transport protocols. On the far left, you'll see the radio protocol stack, and that's something that will probably be new to you. But if you've looked at GPRS air interface before, you'll recognize the RLC and the MAC as some of the protocols, which are also used in 3G, but they're completely rewritten, or they're actually quite different. All in all, what you see is that IP exists on two levels, and that's the purpose I wanted to show you between these two slides. So you actually have IP on IP. On the topmost level, on the application level, you actually have IP between then the user and the application server. But in the mobile network, you actually have IP between various different nodes. So this becomes important from a quality of service perspective, doesn't it? So you've got IP then on the transport layer that has to make sure that all the packet data and the services all get there in time. And on the application level, where we have the end-to-end connectivity, as long as all the lower layers take care of the quality of service correctly, the top level end-to-end should be okay. So now we're moving towards the end. Now this slide is more around some of the specifications in 3GPP. If you happen to be doing any work in that area and you wanted to see which protocols were being used, it gives you a very high level view of what's happening in terms of these specifications. Some of these specifications are very, very detailed, and they show you exactly what message is being sent, what the bits look like, and so on. So most of you probably won't look into that, but it's a handy reference nonetheless. So this is the last slide, and it was interesting, I thought, to include this picture. That's actually myself on the right and a colleague of mine. We took this picture in November 2001. So that is almost 7 years ago. It was taken in Tokyo, actually, and in October of 2001, NTT Docomo had just launched the first 3G network, and we were looking at a video call service. And at that time, obviously, it was pretty new. No one had ever seen one before, so it was quite interesting. I think you can see the picture of myself and the colleague there in the video screen. But what was interesting was that it worked perfectly fine, actually. However, The phone was very big and clunky. It weighed 150 grams, which is pretty huge. The battery ran down within 30 minutes, so you couldn't really do too much. But the call worked very well. It was at a 64 kilobit per second circuit switch call using the video telephony that we discussed earlier today. So we had that service back then. You and I are still not really using it today. And we discussed some of the reasons why that was the case. But I think what we're starting to see now is a move towards a more packet-based oriented system, where we are starting to see a convergence in a number of services within the packet domain. Basic best effort, web browsing, streaming services, push messages like we just heard, and then a convergence with voice as well, which is that use case of Susan and Helen trying to find out where the movie was. So where to tomorrow? I think it's a pretty new space for all of us. Unfortunately, I've been saying this for a couple of years, but I think we're starting to see a big change in the industry with mobile broadband and mobile data coming to the marketplace. So on top of that, I look forward to Skyping and talking with all of you guys on a mobile phone in the future. So thanks for today. That's the end of the lecture, and we'll catch up with you next week. Have a good night. Cheers.